Hello, today's notes are 3.5 descriptive measures for populations, use of samples. Our goals today are calculating the measures of center for populations and distinguishing the difference between the use for measures of center for a sample versus a population. And this really lays the groundwork for future units where we'll be talking about using our descriptive measures from a sample to estimate our descriptive measures for a population. So lots of definitions coming. We're actually going to split this into two videos or lessons, one starting today, and we're going to cover just these key definitions for calculating the measures of center for population with population mean and population standard deviation. And then we'll get to the standardized variable in our next lesson. So the population mean, we'll start by recalling that the sample mean is calculated for a sample of size n for a random variable x using the formula. X bar is how we say that, which is the symbol that we use for sample mean, equals x sub I, the sum of all the x sub i's divided by the n, which is the sample size. And that's just our basic definition for average or mean. Add up all of the x bars and then, or the, add up all of the values in your data set and then divide by how many there are. And then we have, in fact, this is written a little incorrectly with my trying to use the math text in Google Docs, so let's go ahead and rewrite it. The sum of all the x values divided by n. The next definition we have is the population mean. So it's calculated in much the same way with its own notation. So the population mean is represented by the Greek symbol. It's the Greek symbol lowercase m, and it's pronounced mu. And where n, the capital letter N, is the population size. And again, we'll have to kind of rewrite this. Mu equals the sum of all of the observations divided by the population size. Note, for a given variable describing a particular population, there can be only one population mean. You're talking about the whole population. There's only one way to calculate that. However, there are many sample means. One for each possible sample of the population. So we're going to take a look at an example here with the U.S. women's soccer team back in 2008. And we have a record of all the heights in centimeters and weights in kilograms. And we're going to find the population mean. So similar to how we calculate sample mean, it feels like there's nothing different. There's some differences in notation, and that's about it. We're going to add up all of those weights and then divide by how many there are. In fact, the same formula in Google Sheets will work for population mean and sample mean. It's more a matter of understanding, are you talking about, in this case, the whole population of all the soccer players on that team, or just a sample, a part of that group? So I'll just kind of do this for you. Mu, I want you to practice writing that letter. Mu is the sum of all the x values divided by n. If we add up all of these weights in kilograms, we get 1,125. We'll divide by how many there are, 18, and it's 62.5 kilograms. And that's it, population mean. the use of a sample mean. So we'll take a look at this example, estimating a mean household income. The U.S. Census Bureau reports the mean annual income of U.S. households in the publication Current Population Survey. To obtain the population data, the income of all U.S. households would be extremely expensive and time-consuming. We've talked about this before, right? It is also unnecessary because accurate estimates of the mean income of all U.S. households can be obtained from the mean income of a sample of such households. Right? If we have a good sample size, we can use it to estimate. The Census Bureau samples only 57,000 households from a total of more than 100 million. Here are the basic elements of this problem, and then they're also summarized in the picture. The variable, so going back to that term variable, is income, right? The observations are all going to be incomes. The population, again, a review of that term, is all the U.S. households. The population data is the income of all U.S. households. Population mean income, mu, of all U.S. households. The sample, so this is new information, or this is straight from here, samples. 57,000 U.S. households sampled by the U.S. Census Bureau, and our sample data is their incomes, and our sample mean is the mean income X bar of the 57,000 U.S. households sampled. So we're not actually going to go through the calculation. We don't have those values listed here. We're just trying to understand the purpose of using this sample mean to estimate the population mean. So the population data is all of those U.S. incomes and all of the U.S. households, and we pull from there to make this estimate based on this descriptive measure for a sample of the population. Next, we'll talk about population standard deviation. So we have, again, a review. So we have the sample standard deviation for variable x and a sample size of size n from a population represented by the given formula. So s, lowercase letter s, is equal to the square root of the sum of all the differences squared of all the observations, the difference of their, when you take the difference of the observation minus the sample mean, and then square it. And then divide that by n minus 1. There's a very subtle difference to distinguish between the sample and the population standard deviation. And we use this symbol, lowercase letter s in Greeks, it's pronounced sigma, to represent population standard deviation, and just so similar to the one above. The only difference is right here. So that capital letter N instead of the N minus 1. The N minus 1 gives us some cushion room since we're talking about an estimate, whereas when we're talking about the entire population standard deviation, we don't have to subtract that one. We just divide by the total N number of observations. So we have next the population variance of the variable is represented by sigma squared. Just like we have s squared for the variance, that's the sample variance. Same idea. So our second example is using U.S. Women's Olympic Soccer Team, calculate the population standard deviation. Same data, we're just going to do the sample or the population standard deviation this time. And for that one, we would definitely want to use our Google Sheets, and we'll use that formula equals STDEV, but instead of .s for sample, we'll use .p. And we would use all the cells. Let's say we entered all of those data points from our table, all of these weights, There are 18 of them. In those first 18 cells of column A, then we would calculate with this equation. It's equivalent to if we were to take add up all of the values, the difference between the value and the mean squared would be 70,761 divided by the population, and then different ways to do this. We could subtract the mean squared, and that gives us 5.0 kilograms. So like I misspoke earlier. So this 70,761 is the sum of all of those observations, all the weights squared. And then at the end we can subtract that mean squared. It's a little bit of a simpler way to do that. But I would stick, like I said, stick with this formula, and then we don't have to worry too much about this calculation, which takes quite a bit of time, especially when we're talking about populations. Finally, just as a sample mean can be used to estimate the population mean, a sample standard deviation can be used to estimate the population standard deviation. We'll talk about the parameter versus the statistic and the standardized variables in our lesson to come. So that concludes our lesson here on population standard deviation and taking a look at population mean. So some new symbols, lots of similar concepts. 3.5.